Okay, more properties of radicals. Remember that this is the same in 8th grade Algebra 1 and Geometry, literally, chapter 9.1 in each of those books for big ideas. We have the square root of 9x cubed that we're trying to simplify. Well, the square root of 9 is perfect, and it means what times itself equals 9? Well, that's 3. So I know the square root of 9 is the 3. The 3 is going to come out from under the radical. Now I need to think about, well, what is the square root of x cubed? Well, basically, to factor out the greatest perfect square factor, I'd have to have 2 x's to factor one of them out. Remember that the square root of x squared is x. The square cancels out the square root sign. So those are opposites. So if I've got x cubed here, I'll be able to pull one x out from under the radical because it takes 2 to pull one out, and then the other one will stay up under the radical. Another way to think of it is that's the square root of x times the square root of x times the square root of x. That's what that x is. It takes 2 of them to factor one x out from under the radical. So I'm left with the x outside the radical with a 3 and this x under the radical. All right, so the square root of 49 is 7. It comes out from under the radical. And once again, 1x will come out, but there will remain 1x up under it. All right, let's look at this one. The square root of 75, he's not in my perfect square list, so I'm thinking of, well, what number goes into 75 that is perfect? And it's pretty quick to find the 25 goes into that. So let's change that to the square root of 25 times the square root of 3. Remember, 3/4 makes 75 cents. And we'll work with the numbers first, then we'll come back and work with the ends. All right, so the square root of 25 is 5. And then I got the square root of 3 that stays under the radical. He's not perfect, and I can't pull anything perfect out of them. As far as n to the 5th goes, remember you're having to pull out 2 n's at a time to factor out n's. It takes 2. So that means there will be 2 n's that come out from under the radical, but 1 n will stay inside the radical. You can think of it like this. It takes a second to write it down, but it might help you understand it better. There are 5 n's, right? And it takes 2 to factor 1 out. So there's 1, there's another. So 2 n's came out and 1 n stayed up under the radical. And then this would be simplified.